All right, let's get started. Welcome. Hopefully, everybody's week has been going great thus far. We're going to start today with lesson four. So please make sure if you have not looked at lesson three, you need to make sure you have looked at that first before you're looking at this one, because if you have not, it's going to be a little bit confusing what we talk about today. So we're going to go straight into it. So with today's lesson, we're going to be looking at simplifying exponential functions. So by the end of this lesson, you'll be able to basically simplify any exponential function that has any positive or negative exponents. And we're going to look at the properties of exponents as well. All right. But before we get into that, as normal, we have a do now. So for our do now today, you have a function. It is 2 times 2 to the power of x plus 3. So the first thing we want to do is that we just want to fill in this chart. Okay, so I'm giving you a bunch of x values here. So I want you to go ahead, plug them into your function, and see what you get. Once you have done that, at the bottom of the page is we've dealt with these types of problems from the previous lesson. So based on the function that you have at the top, what we want to identify is if we're dealing with the growth or decay model, what's the growth factor, what's our y-intercept, what's our horizontal asymptote, identify the domain and the range, and then we want to take all this information to create our graph. So take 10 minutes to work on the do now presented here. And when you unpause this video, when I'm done giving instructions, you're going to see this table here filled out, and then we will go over this bottom part together. So go ahead and pause your video at this time. All right, we are back. So I've gone ahead and filled in this table from the do now. So if you have not done so yet with your own paper, please make sure you got this filled in. Or if you have filled it in, just make sure your answers match what I have here as well. All right, but we're going to take this information now and we want to eventually look at graphing it. But before we graph it, there's a couple of characteristics we need to talk about first that will help us with that. So first off, looking at this function at the top, we're trying to identify if we have a growth or decay function. In this case, what we have is a growth function. Why? Because if we look at our growth factor, the growth factor here is 2. So our growth factor is 2. And since this number here is bigger than 1, that is why we know that we're dealing with a growth model. Now, our growth factor is 2. Our y-intercept, we've actually kind of filled this in from the table. This point here, 0, 5, that is your y-intercept. All right. Another way you can identify that is that if you look at our function, you take your initial value here, which in this case is 2. And since we have a vertical shift here of 3, what we need to do is that we need to add 3 on top of that. So if we do 2 plus 3, that is 5. Hence why our y-intercept is 0, 5. Now for our horizontal asymptote, we look at y equals your k value. And your k value is whatever you're adding or subtracting at the end of your function. In this case, since we're adding 3, that means that this here is going to be our horizontal asymptote. So y equals 3. For your domain, we talked about this in our last lesson. We said that for any exponential function that you deal with, the domain for it is always going to be all real numbers. So this is never going to change. The only thing that will change, though, on the other hand, is what your range is. Now, your range, you start with whatever your horizontal asymptote is, which in this case is 3, and we're just going to take that all the way to infinity. Okay, so now we're going to take all of this information here and we're going to graph it on the side. So if you looked at the last lesson, there's 3 steps that we have to do. First thing is we're going to plot our y-intercept at 0, 5. So 1, 2, 3, 4, 5. So this is our y-intercept right up here. Then we have our horizontal asymptote, which is located at 3. So I'm going to draw a dotted line at 3 here. And again, this represents our do not cross barrier. So our graph is never going to go past this point or past this line. And then the last step with this is, well, we're dealing with either a growth or decay model because that is going to tell us how our curve is going to look. So because we are dealing with a growth model, that means that our function or the curve is going to look like something like what I wrote here. So that means that if I replicate that over here, that means that our function is going to look something similar to what I have drawn here. So this isn't a precise or super accurate representation of the function, but this is just drawn to show you an idea of how it should look. Okay, so that is how we deal with graphing exponential functions using characteristics that we can identify from any function given to us. All right, so this is what we covered in our last lesson. So we're going to not really look at graphing so much in today's lesson, but what we're going to look at is more so simplifying exponential functions to make it look a little bit cleaner if we need to. So with that, if we were to move to the next page, excuse me for a second. All right. On the next page, we do have a couple of example ACT problems that were given in previous years. We will actually look at these problems together, but I'm not going to look at it right at this point. I'm actually going to skip past these three problems on page 16, and we're going to go to page 17 for a moment. Okay, so skip past this. We're going to come back to it, but for now, I'm going to move to page 17. Now, in order for us to simplify exponential functions, there are some rules that we should get ourselves familiar with, so that way when we see them down the road, we're not we're not like too startled or we're not shocked in terms of how we can go about simplifying them. In fact, some of these rules that we're going to go over together in a moment, we've actually used from previous lessons in the past from different units, specifically when we talked about polynomials. All right. So as you can see here, there are a total of 7 rules that we have in terms with exponents. So we're going to look at what each of these are. We're going to look at an example here on the side so that way you know, hey, this is the rule and how it works. Okay. So the first one is what we call the product rule. Now, for this, here's an example of what we're talking about. Let's say you had something like 2 to the 10th power times 2 to the 5th power. Now, we have seen a problem like this way back when we talked about polynomials from Unit 1. We said that if we have two things that have the same base but have different exponents, what we can do to simplify this is that we can take the exponents and add them together. So in other words, if we're going to multiply this out, this is the same as doing 2 to the power of 10 plus 5. So if we add the exponents together, 10 plus 5, this is actually equal to 2 to the power of 15. So in other words, the product rule says that, well, if you have two things that have the same base but different exponents, really all you're doing is just to simplify it, you're going to add the exponents together. Now, for the second rule, when we're talking about the quotient rule, it's going to be the opposite. This is where we're going to have a case of subtracting exponents. Okay, so an example of this could be something like, what if we had 4 to the 9th power and we're dividing that by 4 to the 3rd power? Okay, so in this case, if we want to simplify this, we need to subtract the exponents. So we're going to do 9 minus 3. So if I did 9 minus 3, this is the same as writing 4 to the power of 6. Again, these rules should not be uh, alarming, or these rules shouldn't really be new to us because we've actually toyed around with these in previous units. All right, so that's that one. The next one here is what we call the power of a power rule. So for this example, let's say you had something like the following. Let's say you had 5 raised to the fourth power, and on the outside of these parentheses, you have another exponent of 4. So you have two exponents here, hence why we call it the power of a power. Now, what you would do in this case is that you would take these two exponents and you are actually going to multiply them. So if I did 4 times 4, that's 16. So in other words, this here simplifies to 5 to the power of 16. So the key here for this is that if you're dealing with something like this, you're just going to multiply your exponents. Okay, now these next two rules that we have here are kind of a combination, excuse me, they're kind of a combination of the previous three rules that we've looked at together. Okay, the first one is the power of a product rule, and the second one is power of a quotient rule. So for this, the first example for this case here is, let's say you have an example of, I don't know, let's say x cubed times y squared, and then we're raising all of this to the fifth power. So if we want to simplify this down, what we want to do is we're still going to use this rule up here, but what we're going to do is that we're going to multiply each of these exponents by the exponent on the outside. So what we're going to do here, if we want to simplify this, we're going to do x to the power of 3 times 5, and then we're going to do y to the power of 2 times 5. So in a sense, we're kind of like distributing this 5 into each of these exponents. So if I did that, well, 3 times 5 is 15, and 2 times 5 is 10. So in this case here, this simplifies to x to the power of 15 times y to the power of 10. So the key here is that we're really just distributing that outer exponent. That is going to be the same for the second rule here, where we have power of a quotient rule. So for this rule, same idea, but this time if we had, instead of multiplying them, what if we're dividing? So if we have like what we have here, it's still going to be the same idea. We're going to distribute this 5 into both of these exponents. So really you have x to the power of 15, because that's what 5 times 3 is, divided by y to the power of 10. Now, for the second to last rule, we have it talks about, well, what happens if you have an exponent that is negative? So, like, what if, as an example, we have x to the power of -4, and I want to rewrite this. All right, if you have a negative exponent, what you're going to do is that you're going to actually write this as a fraction. Okay, well, how does this fraction look? Well, on the bottom of your fraction, you're going to write the same thing here. It's just that except instead of writing -4, it's just going to become positive. So here we're going to write x to the power of 4 on the bottom. And on the top of this fraction, you're just going to write the number 1. So in other words, if you have a negative exponent, you're going to write it as a fraction where on the top is the number 1, And on the bottom is just itself. It's the same thing, just get rid of the negative sign. All right, and then lastly, favorite one, the zero exponent rule. If you have anything that is raised to the zero power, like 5 to the 0 or x to the 0, anything that is raised to the 0 power is automatically going to equal 1. Okay, so if you have a 0 exponent, automatically that just simplifies down to the number 1. All right, now all of these rules that we have covered, these will be your best friends in terms of simplifying anything that has exponents attached to it. All right, and so just to give us some practice with these problems here, we're going to go back to the ACT problems that we had listed on the previous page. Now that we have covered those rules, because they will be helpful for us when answering these questions. All right. So number one, we've actually seen this problem before, but I want to go over it again. We have this expression listed here, and we want to simplify it. Now, first things first, notice here that this term in the middle does not have an exponent. We have talked about this. We said that if a variable does not have an exponent attached to it, assume that it is the number 1. Now, if we want to multiply all of these out, if we remember from before, or we can look at the page that we filled in together. This is an example of the product rule. So in this case, what we're going to do is that we're going to add all the exponents together. So in this case here, if we add all the exponents together, we're going to do 4 plus 1 plus 8. And if we add those together, we get 13. So we check our answer choices here. That is letter C. Okay, so now we go to number 2. Number 2, you have a to the power of 10, b to the power of 8, and we are dividing that by a to the second power and b to the power of 8. So this here is an example of the quotient rule, where in this case, we are going to subtract the exponents. We're only subtracting exponents with terms that match. So, and that means that we're going to subtract the exponents for A, and then we're going to subtract the exponents for B. So if we did that, we got A, subtract 10 minus 2, times B, and then we're going to do 8 minus 8. So first off, 10 minus 2, that is 8. So we have A to the power of 8 times. If we did 8 minus 8, we get 0. So we have A to the power of 8 times B to the power of 0. Hey, we have a 0 exponent here. So if we go back to the last page on page 17 here, we said that if you have an exponent of 0, automatically that is equal to 1. So in this case here, this part is just nothing but the number 1. So really what you have is that you have a to the power of 8 times 1. And anything multiplied by 1 is just itself. So that means that for number 2, our answer is going to be answer choice A. Now, number 3, okay? Number 3 is a little bit tricky, but we're going to do it together. For number 3, we have 2 to the power of 4, and that is raised to the power of 5 on the outside. And then on the bottom, we have 4 to the power of 5. And then on the outside of that, we have a 4 exponent. So I know you might not see it on this video, but just make sure you're following along in your packet as well, because it might be seen a little bit more clearer on there. But okay, notice here that we have 2 exponents next to each other. This is a power of a power. So if we have 2 exponents like this, what we have to do is multiply them. So on the top, we have 2 to the power of 4 times 5. And on the bottom, we have 4 to the power of 5 times 4. So if we do that, 5 times 4 is 20. So we have 2 to the power of 20, and we have 4 to the power of 20. Now, if we take our answer as it is, note here that it does not match anything that we have listed here. So the question is, well, what do we do? All right, so first off, I want to make sure that these two things match, because if they don't match, then I can't subtract the exponents. So I can't do the rule that we did before. All right. But what one thing I do know, if I think about it, we can all agree that 2 to the second power is equal to 4. This we already know. So why don't I use this and substitute it here? So instead of writing 4 to the power of 20 here on the bottom, I'm going to rewrite this as 2 squared, because that's 4. And then we're going to raise that to the power of 20. Okay, now look at what we have here. We have an exponent on the inside and we have an exponent on the outside. So that means what I can do is that I can take these, multiply them. So 2 times 20 is 40. So what we have on the bottom is that we really have 2 to the power of 40. Now, because we have our bases, they match. Now what we can do is that we can take our exponents and we can subtract them. So this becomes 2, and then we have 20 minus 40. So if we do 20 minus 40, that is 2 to the power of negative 20. Okay, now we have a negative exponent, last step. If we go back to the rule from before, we said that if we have a negative exponent, we have to write it as a fraction, where we write the same thing on the bottom without the fraction, and we write the number 1 on the top. So that means that in our case here, we can rewrite this as 1 over 2 to the power of 20. And now if we check our answers, we have something that matches what we have here. That is answer choice E. All right, so that is how we look at simplifying with exponents. Again, these rules that we filled in together at the top of page 17 here, they will be our best friends with simplifying exponential functions, because we're going to be using these rules nonstop. And so if you get yourselves familiar and comfortable with these rules, the good news is that for this test down the road, you don't have to memorize them. They will be given to you, or you can keep them on you. That'll be helpful for us as we move forward. Okay, so now here's what you got left. The last thing that you have left is at the bottom of page 17, you have 4 more practice problems. Again, the key for these problems here is that you're trying to use the rules from above and trying to simplify this down as much as you possibly can. Okay, so if it helps you out, we're going to do one of these problems together just so you have an idea of what we're looking for. And then the rest of the problems you'll have to do on your own and make sure you can complete by the next class period together. All right, so if we look at number 1 is pretty straightforward. Let me go ahead and let's go ahead and let's do part D. All right, so we're going to do part D together actually. So we want to simplify this thing down here. We have x to the power of negative 3 times x to the power of 4, and we're dividing all that by x to the power of 8. All right, first thing, if I want to simplify this, let's look at trying to simplify the top. I have two things that have the same base but different exponents. So that means, hey, this is a product rule. And if I go to the top, all I have to do is add the exponents. So on the top here, I'm just adding negative 3 and 4 together. Now, negative 3 plus 4, that is equal to 1. So I have x to the power of 1 divided by x to the power of 8. Now, this turns into the quotient rule where I'm dividing two things. So what that means is that I need to subtract the exponents now. So in this case, to simplify this, I need to do x to the power of 1 minus 8. And if I did 1 minus 8, this becomes negative 7. But hey, okay, last thing, I have an exponent now I have an exponent that is negative. So if I go back to my negative exponent rule, that means that we have to rewrite this as a fraction. Okay, so at the top of our fraction is going to be the number 1, and on the bottom, we're just going to write x to the power of 7, getting rid of that negative sign. I can't do anything more with this, so that means that this is my final answer. All right, so that is how we do part D. So similar to what we just did for part D, you need to do the same thing for part A, B, and C. That is going to be your independent practice. And that is what you need to make sure you complete by the next class period in order to receive credit for completing your notes for this lesson. All right. Now, the last thing you have to do as well, besides finishing these notes, is that making sure that you complete the exit ticket for this lesson as well. All right, so give me one moment as I pull this up. So as I said in previous lessons, all the exit tickets for the first 4 lessons thus far in this unit, they all need to be completed by 11:59 on Friday. So you'll have a little bit of time to complete this. So it's going to be important to make sure that you're on top of everything and making sure that you're not trying to do all this stuff last minute because it does add up and you don't want to feel like you're overstimulated and feeling like you have a lot to do in so little time. So try to make sure you get this done as soon as you possibly can. Now, similar to before, depending on what day you have me, there's two different access codes for Illuminate in order to get to this exit ticket. So I'm going to share both of them with you. All right, if you have me on A day, the code that you will use, let's push this down a little bit more. The code that you will use to get to the exit ticket, it is S8X92FC. So that is your code if you have me for A day. If you have me on B day, the code that you will use to get to the exit ticket is N67. Shut up, I already know about that. 3HCS. So that is your access code for your Illuminate exit ticket. And lastly, like I said before, the due date for this is 11:59 on Friday, November 7th. All right, so even if you don't finish this on Wednesday or Thursday, you will have time to complete it on Friday as well. Friday, I believe, is an A day for us. So my A day, you'll have time in class to work on this if you need to, in order to make sure you get this knocked out and out the way and not having to worry about it over the weekend. All right. So that being said, this is actually a pretty quick lesson that I just went over. So you should have a lot of time to kind of work on this independent practice. And if you're working on this in class, the good news is that you should have a little bit extra time now as well to go back and working on any of the old lessons if you still need to. Whether that's making sure you get the notes knocked out in order to get credit for it still, or working on those old exit tickets if you still have not got those knocked out so you can get credit for that as well. All right, because by the end of the week, I plan on updating all the grades for exit tickets, making sure I update the grades for if you completed the lessons or not. And I'm working with the subs. I'm making sure that I get those names so that I can update those grades for you as well. But other than that, the rest of this time is yours to get done with whatever it is that you need to get done. All right. So that being said, um, if you do have questions, more than welcome to reach out to me. Otherwise, I hope you have a great rest of your week. Enjoy your weekend. And then we will move forward with lessons 5 and 6 next week. Until then, I'll see you guys later.